Welcome back. In section 1.9, we will introduce you to the distance and the midpoint formulas, as well as a discussion of circles. The distance formula. If we have 2 points and we want to determine the distance between those 2 points, we need the distance formula. So if we have 2 points, let's say we have 2 points, x1, y1, x2, y2. So let's assume that we have these 2 points. I say this is x1, x2. x1, y1, x2, y2. And we want to determine the distance between these 2 points. All right, let's see how to do that. So we want this distance d. So we've constructed a right triangle here with coordinates of this point, x1, y1, x2, y2, and x2, y1. So what is this horizontal distance? The distance between x1, y1 and the point x2, y1. So the distance here would be this horizontal distance, the absolute of x2 minus x1. And it's the absolute value because distance is a positive quantity. What is this vertical distance? This vertical distance would be the absolute of y2 minus y1. And now, if I want the distance between the 2 points, it's just a matter of using the Pythagorean theorem because this is a right triangle. So therefore, I can write that d squared, the hypotenuse, d squared is x2 minus x1 squared plus y2 minus y1 squared. So we want d and not d squared, so I can express d as the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And this is the distance formula. This is the distance formula. Let's look at an example. So we want to find the distance between the points a -1, -3, and 2, 3. In order to do that, we're going to use the distance formula. Recall that the distance formula is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. All right? So we're going to make the substitution. X sub 2 is 2 minus x sub 1. X sub 1 is a -1 squared plus y sub 2. Y sub 2 is 3 minus y sub 1 y sub 1 is a negative 3 squared. Let's simplify. So we have the square root of 2 plus 1 squared plus 3 plus 3 squared. The square root, 2 plus 1 is 3, so we have 3 squared plus 3 plus 3 is 6, 6 squared. So therefore, with the square root of 3 squared, which is 9, plus 36. The square root of 9 plus 36 is the square root of 45. And if you like, we can simplify this. We know that square root of 45 is 9 times 5. Square root of 9 is 3 times the square root of 5. So the distance D is given by 3 times the square root of 5. We want to now introduce you to the midpoint formula. So given 2 points, x1, y1, and x2, y2. So given these 2 points, if we connect these 2 points with this line segment, we then might want to determine the midpoint of that line segment. So the midpoint formula is defined as to get the x coordinate of that midpoint, which is going to add the x coordinates and divide by 2 to obtain the y coordinate of the midpoint. We want to add the y coordinates and divide by 2. So this is the midpoint formula. So now let's use the midpoint formula to answer the question. So find the midpoint of the line segment within points 1, 2, and 7, negative 3. All right? So the midpoint, all right, the x coordinate of the midpoint. So let's add the x coordinates. So if I add the x coordinates, I'm getting 1 plus 7 divided by 2. To obtain the y coordinate of the midpoint, we want to add the y coordinates. So if I add the y coordinates, I have 2 plus a negative 3 divided by 2. All right, so what do we have here? 1 plus 7 is 8. 8 divided by 2. 2 plus a negative 3 is a negative 1 divided by 2. So therefore, the x and y coordinates of the midpoint are 4 and a negative 1/2. So these are the coordinates of the midpoint. We will now introduce you to circles. All right, what is a circle? A circle is a set of all points in a plane that are equal distance from a fixed point. The fixed point is called the center of the circle. So here's the center, and now the radius. With a center, HK, and radius R, we can now write the standard form of the equation of the circle. The standard form of the equation of a circle is given by x minus h squared plus y minus k squared is equal to the radius squared. Let's write the standard form of the equation of a circle with center 0, -6, and with a radius of 10. All right, so we have a center. So the center, HK of 0 minus 6. So H is 0. K is a -6. The radius is 10. So the first thing we want to do, let's substitute into the standard form here. So recall that the standard form is what? X minus h squared plus y minus k squared is equal to the radius squared. So what do we have here? So we have x minus h is 0, squared plus y minus k. K is a -6. Quantity squared is equal to the radius squared. The radius is 10, so that's 10 squared. Let's simplify. We have x minus 0 squared plus y plus 6 squared is equal to 100. Well, let's see. X minus 0, so we have x squared plus y plus 6 squared is equal to 100. So in standard form, the equation of the circle is expressed as x squared plus y plus 6 squared is equal to 100. Now we have another form in which we can express the equation of a circle. It is called the general form of the equation of the circle, which is given by x squared plus y squared plus dx plus ey plus f is equal to 0. Now, we can actually convert an equation from general form to standard form. So we can actually, given the equation as we are here in standard form, we can actually rewrite it in an equivalent standard form. And we do this by completing the square on x and y. Let's look at an example. So we have an example. We want to write in standard form. We want to take the equation, which is expressed in general form, and rewrite it in its equivalent standard form. And in order to do this, we have to complete the square on x and y. So let's complete the square. So we have x squared. First, let's rearrange the terms. 4x plus y squared minus 4y is equal to 1. So what do we have here? This space is for completing the square. So what must I add to this binomial to make it a perfect square trinomial? So as you may recall, we complete the square by determining b over 2 squared. B is the coefficient of the x term. So this is going to be 4 over 2 squared. So that's 2 squared is equal to 4. So in order to complete the square, complete the square on x, we're going to add 4. We're going to do the same thing here. We need to complete the square. In order to complete the square again, we need b over 2 squared. Again, b is the coefficient of y. So b is a negative 4. So we have a negative 4 over 2 squared. A negative 4 over 2 is a negative 2. A negative 2 squared is 4. So to complete the square, I'm adding 4. But notice, did you notice one thing that I've omitted? I added a 4 here to the left-hand side of the equation. So I must also add a 4 on the right-hand side. And likewise here, I added a 4, so I've got to add another 4 over here. All right, so let's see what we have then. So we have, let me just rewrite what I have. X squared plus 4x plus 4 plus y squared minus 4y plus 4 is equal to 9. So that's what we have so far. All right, we have a perfect square trinomial. Upon completing the square, let's factor this. If we factor the perfect square trinomial, we get x plus 2 squared plus, again, if I factor this perfect square trinomial, we get y minus 2 squared is equal to 9. So actually, we have expressed the equation of the circle in standard form. This is standard form now. All right, this is standard form. X plus 2 squared plus y minus 2 squared is equal to 9. In standard form, we can immediately identify the center of the circle. So the center of the circle here, HK, is going to be a negative 2, 2. The radius of the circle, remember, in standard form, the right-hand side is r squared. So to get 9, r is 3. So we're going to use this information to obtain the graph of the circle. So first, let's find the center of the circle. The center of the circle is going to be a negative 2, 2. So in the rectangular coordinate system, let's find that point. A negative 2, 2 is here. So this is our center. With a radius, the circle has a radius of 3. So a radius of 3. So our circle is going to so this is a quick sketch of the circle with these features.